Hey folks, you have done a great job so far keeping up with me. This program that we've written together is not that simple. It's got some complication to it. And if you understand it at all, you're doing great. And certainly if you got it to work, well done. Okay, and regardless of how well you've done up until now, you can always look at the code here and copy it down and enter it yourself and get it to work. One of the things that many people have discovered is that one little tiny mistake and the whole thing doesn't work properly. So, for example, an awful lot of people, when they got down to the Serena, they had some problems. Either they forgot to put in, well, one real common problem that was interesting was people would have card with a capital S up here, and then card with a capital S here, and then card with a lowercase s down there. And it turns out that if you refer to card with an uppercase s or card with a lowercase s, the computer does not know that those are the same. The computer thinks it's two different. At least when you're writing computer programs, you've got to be careful. They're case sensitive. What else? I think that was one of the biggest problems. Another thing, I did see some people just forgot to put in the card S equals 0 up here, and of course that's going to cause some problems. Okay, so anyways, here's the complete code, and I'm hopeful that when you ran, I'm hopeful you ran it a few times and you discovered, wow, this actually completes one complete trial of a simulation regarding buying boxes of cereal, and trying to see how many it took to get a complete set of sports cards, including Serena, Danica, and LeBron. And if you run it multiple times, like this time here, I ran it, and I had to buy 15 boxes of cereal before I got the complete set. But if I run it another time, maybe only 7, and another time only 3. So it's pretty interesting, and hopefully you'll notice that this is kind of a similar result that we got when we tried to manually conduct the trials in the simulation using the random digit table. So anyways, the thing that's nice about this is that you don't have to do it. You can just let the computer do it. So one of the things that we tried to do was we did this type of simulation for about 20 trials, and then we took the count for each trial and we averaged them all together so that we could say, on average, it took so many boxes of cereal to get a complete set. That's the beauty of simulation, is it lets you do that. We use randomness and the average in order to try to figure out what might happen in the real world. So anyways, if we wanted to, we could simply use this code over and over again to conduct trials. By the way, this program does save a ton of work, because it only took one little click and a blink of an eye to buy 16 boxes of cereal and determine that that was a complete set. And not only were we able to buy a bunch of boxes of cereal faster than looking up the random digits, but it's probably more accurate. I'll bet you made a mistake several times when looking up the random digits. Anyways, so if we wanted to, let's say that we wanted to do 100 trials to get a better sense of exactly what was happening here. Well, if we wanted to do 100 trials, we could just run this over and over again. So 16, write that down. 6, write that down. 4, write that down. And just gather them all up, add them all together, and then divide by 100. And then we could get the average number of boxes that we need. But we're going to go one step further and fully take advantage of the power of the computer. And what we're going to do is we're going to take the program we have so far, and we're going to wrap it in another loop. You'll notice that we're using a while loop in order to conduct all the to buy all the boxes of cereal in one trial. What we're going to end up doing is we're going to use a for loop in order to repeat this over and over again, repeat all of this over and over again. So let's get into it. let's go ahead and let's start our looping right before we we'll start the loop before we initialize those variables, because those variables need to be set to 0 for every trial. In other words, we don't want to count how many boxes of cereal we bought well, how can I say this? If we're going to start a new trial, we want the number of boxes of cereal that we bought to be 0. So for that reason, we want to make sure that count equals 0 when we start every new trial. And every time through the for loop is going to be one trial. So we're going to go ahead and say for x in x range 1 comma max trials. And now the thing is this, I want to introduce you, some of you guys had problems with the indenting, and one thing that we're going to do to make sure that we've got a lot to indent right now. I want all of this stuff below here to be looping. So in order to make sure that happens, it all has to be indented 1 under the for statement. So what I'm going to do is I'm going to highlight all this code, and then I'm going to hit the tab key 1 time, and that moves everything over 1 tab, and that's enough to make it so this will do all the looping. Now, the only thing is I'm saying do this max trials number of times, but I haven't set max trials to a value. So we're going to go ahead and set max trials. And by the way, I hope you notice that the T is in uppercase. The variables are case sensitive, so if I use an uppercase T here, I better be using an uppercase T here. And you might wonder, why am I using uppercase? Well, it turns out sometimes in computer programming, we like to use long variables that are very descriptive of the information that they hold. And when we use long variables, it's really kind of nice to be able to use uppercase to sort of separate the words out that are put together to make that one variable name. Okay, anyways, before I forget, this code's not going to run because I need to put a colon at the end of that for statement. And max trials we'll set to, I don't know, we'll set to 10 at first just to see if this thing even works. And one other thing is that after I'll show you in a second. We'll go ahead and run this. So I think what this should do is it should get me 10 counts. It should get me, I should complete one set of sports cards and get a count, and then the next, and then the next, and the next. And I'm sorry, it won't get me 10. What we learned earlier is that if I put the number 10 here under max trials, it'll do it 9 times. So maybe just for good luck, I'll make that 11, and now it'll do it 10 times. It's a weird convention. It's not this way in every programming language, but I'm just going to go with it for now. Okay, so I'm going to go ahead and hit run. And when we do, let's see here, I've got count equals 7, count equals 3, count equals 3, count equals 6. So if I scroll, I can see, okay, well, it went and bought a bunch of boxes of cereal, and every time it got a complete set, it told me how many boxes it were required. That's pretty cool. By the way, I want to point out, that's really cool. That's the computer doing a lot of work for us. I'm just kind of curious, if I made this 101, like the Dalmatians, I wonder what would happen. It'll probably take a little bit of time, but let's see how much time. I'm just curious. Okay, it's taking some time. Now, there is a way to speed it up, and one way to speed it up is not to use all these print statements. So we could get rid of those and things would move a lot faster. And I don't even have to delete the print statements. I can just put the hashtag in front of each one, and that'll be fine. That'll be enough to speed the whole thing up. In fact, maybe just for the heck of it, I'll show you how much faster it runs with that. So let me go ahead and hit run. Still seems like it's taking a little while. Maybe it's because of all the counts and all the numbers. So let's go ahead and let's get rid of that, and we'll just do the counts. Let's see how long it takes. So here we go. That was faster. Okay, so now the truth is, in normal computer programming, normally removing print statements like that is not going to slow the computer down very much. We're programming in a web page, and that's why it makes a big difference. Okay, so Anyways, I've got to be real careful when I add the hashtag and delete it that I don't change the indentation. Otherwise, the program will stop running properly. Okay, now there's something that I hope you notice here is I can still take these 100 counts and I could still add them all up and average them, but that's still too much work. I want the computer to help me out here. So what I'm going to do is at the very end of my code, I'm going to go ahead and try to total all this. So after I do all the looping, after I do all the, let's see here. Oh, I know, not after I do all the looping, but after I'm done with one trial, what I'm going to do is I'm going to say total equals total plus the current count. Okay, so what this will do is it'll take each one of these counts and it'll add it to a total. Now, the only problem is that total has to start at some value, so I need to remember to set total equal to 0 at the top so that it's adding on to something. Okay, so I believe that will run properly. And then at the end, I'd like to print all that. Now, if I want to print the total, but I don't want to print the total every time I go through the loop, what I'll do is I'll backspace so that there's no indentation. And then I'll go ahead and say print, and I'll put in total. Now, if I want to get really fancy, I could even have the computer calculate the percentage of times that, let's see, hold on one sec, let me think about this. Sorry, not percentage. If I want to have the computer calculate the average for us, it can do it. Check this out. Watch how easy it is. Actually, I want a little, I'm going to remind you that this is all the code that we're using, okay? And before I tell you, I want you to pause the video and I want you to see if you can figure out how to have the computer calculate the average. That would be really cool. Okay, I'm hopeful that you figured it out. Let's compare notes. I think in order to compute the average, I'm going to say print total divided by max trials. Now, I might have to do max trials minus 1 to get the exact correct amount, but it'll be close either way. Just to be safe, though, I'm going to do parentheses, max trials minus 1. There we go. Now, that should give me the total of all the cereal boxes we had to buy and the average at the end after everything is done. It's not going to print it every time through the for loop because we unindented. So this stuff is not inside the for loop. Let's see. Oh, and you know what? Maybe I'll just make a comment note here. This will print the average of all trials. I love it when I can get the computer to do that extra work for me. Okay, so I'm going to go ahead and I'm going to say a little prayer. Please let this work, and then hit the run button. Here we go. Oh, it's going to take a long time again because I put all those print statements back. Now, one of the things I like about having all those print statements in there is that you can really see that it's actually doing what you think it's doing, okay? As opposed to when we take them out, you just have to assume, you would just have to hope and pray that it's actually doing something and there's not just black magic going on. Anyways, at the end, we figured out that it took, on average, about 29 boxes of cereal in order to get a complete set. Now, I'm curious whether it does that if we do that again. I am going to speed this up. Let's go ahead and let's get rid of some of these print statements because I'd like to do. Oh, you know what? Actually, I'm not going to do it. I'm going to let you guys do it. You guys are going to finish off all this code. You're gonna make your code match mine. It's gonna have all this stuff in there. And for those of you who want to see it all in one quick screen, I think I can do that for you. There you go. So if you guys want to pause it and then zoom in on that, maybe you can just see it all in one glance. And then you guys are gonna run it, and you're gonna do this multiple times. Oh, by the way, the other thing is maybe we want to do more trials. Like instead of 101 trials, let's do 1,001 trials. Okay, but I'm gonna let you do that, and then after you do, I'm going to go ahead and have you do a screenshot and show me the results. Now we're kind of at the end of this sports card simulation. We now have some code that will simulate this thing. It'll simulate doing trials just like you did with the random digit table. And you can tell it to do as many trials as you want, which is like what you had to do the other day when you had to do 10 or 20 or whatever the number was of trials that you had to do. And we've got our code to do all that. And I'm hopeful that you are finding this to be as exciting as I am, because I just think this is the coolest thing. Oh, by the way, sorry. When it comes to having all the code, I was missing a couple of lines at the top. Sorry about that. I forgot about that. Okay, so we got to go all the way down to 36. Oh, good. Okay, there we go. There's all the code. Okay, so anyways, now that we're done with this, you're gonna write the code. You're gonna show me that that it's working, and you're gonna give me some results that I'll specify in the Canvas module. But the other thing I'm gonna have you do is I'm gonna give you a problem that it requires simulation, and I want you to write your own program using these techniques in order to run a simulation and do all the trials to find answers to another question that's similar to this, but still different. It's a problem that you wouldn't be able to get the answer just by guessing off the top of your head. Your intuition would fail you. But even if you knew how to calculate the probability or the average on your own, it would be hard to do. But using the simulation, the computer will get you the answer quite easily. Sort of like we're getting the answer for how many boxes of cereal do you need to buy to get a complete set. We're going to have a pretty good idea of how many boxes of cereal we need to buy when we do 1,000 trials. That'll be getting pretty close to the real number that we actually expect. Okay, anyways, go forth. Good luck. I hope you enjoy. Have some fun with this.